before that, a quick introduction. While I was there earlier in the morning as well, while I was giving updates, I am Atulpriya Sharma, and I come from Hyderabad, India, the land of Hyderabadi biryani, one of the most popular dishes from my city. I work as a senior developer advocate at InfraCloud Technologies. I'm also a CNCF ambassador and the co-chair of the platform working group. I've been in the cloud native space for about 4 years now, and got time to spend in the community, understand the various projects that we have, and platform engineering is one of them where I spend some time. You can connect with me on my LinkedIn and Twitter and social media, where I speak about things around cloud native, Kubernetes, DevOps, platform engineering. Outside of work, I am a big-time foodie and a travel blogger. I've been doing that for a couple of decades now. So when I'm not working or speaking or creating content around platform engineering, you can find me at a restaurant or a cafe trying out new food. So again, here's my socials and my blog. I'm here in London for a week after KubeCon. So I'll probably be going to a lot of places to explore. So if you have suggestions, you can give me about that. Now, since I am a food blogger, obviously I talk food. And what you see over here is a typical recipe of a dish that you want to make. And platform engineering is something which is very similar to cooking and kitchen and the recipe thing. I've spoken a lot about platforms in the past where I've given the analogy of kitchen, chefs, cooking. And abstractions, I feel, is exactly like the ingredients that you need for making a particular recipe. The moment you have something in excess, the taste is very bad. The moment you reduce some spices from your dish, it becomes absolutely bland. So a platform is similar in that particular nature. The more abstractions you have, it might be a lot more complex, but then the lesser abstractions that you give to your developers, it becomes less flexible. So that's exactly what I'm going to focus on in the next few minutes. And as all of us here know about platforms and abstractions essentially they give us benefit in terms of 3 ways. First of all, they create structure through simplification. That's the whole idea of abstraction within platforms. Because they abstract out a lot of stuff, they make things simpler for the developers. What they also do is they make complexity a little more manageable. Since now you have a lesser number of knobs to turn around and work, so it makes complexity a little more easier. And then also, they actually hide a lot of implementation, which basically also leads to a lot more value. So you see a lot more value coming out of it, but you don't see a lot of complexity involved. So through abstractions, these are the key things that actually benefit when it comes to through abstraction. Now, a typical abstraction dilemma, here's a use case, a hypothetical situation, which I'm sure a lot of you, if you are part of platform teams, you would have come across. So let's imagine that there's a platform that is created by a team, and they have created a database provisioning abstraction for their teams. And there are a few other teams, application teams within the company who is using the particular platform, and everything is going well for the various teams that are involved. Now, suddenly, the mobile team comes up and says that, hey, I need a separate PostgreSQL plugin for my particular application. And that's currently not offered as part of the platform that your team has already deployed. Now, here's a dilemma or a question for the platform engineering team. How do they handle this request? When the team says that I need something which is not part of your platform, how do I actually, as a team, understand and respond to that? So there are 4 ways that the team can actually address that particular issue. Number 1, the easiest way is add the configuration option. The mobile team says that I need this, you add those configuration within your platform. That's the easiest thing. But one of the major problems with this is it is going to make your abstraction more complex. So earlier, when developers were dealing with 3 or 4 options to deal with, now suddenly you have 10 options there, and everyone's like, OK, I don't know what to choose. So that's the complexity you add by choosing the easiest option. Second thing, what you can obviously do is you can give a one-off exception that, hey, these are one-time requests that you are coming up with. I can create an exception for your use case. But then the problem here is that you break the standardization. The whole idea of having a platform was to have a standardization across teams. But because of that one-off exception, you are actually breaking the standardization that you have. The third thing that you can do is you can tell them that, hey, this is what you have to work with this. I cannot give you any exceptions. Now, in such cases, you are actually reducing the scope of innovation for your team, for the team that needed the functionality, and you are basically restricting them. And last option is you allow them to create whatever they want. So basically, you are allowing them to bypass your platform, which essentially means there would be a shadow IT team that's being created. So now, what option as a platform team or an organization you choose, right? And that's exactly what I call as, and based on the option that you choose, you have something called as abstraction debt. This is a term that I have coined because I'm sure a lot of us deal with technical debt a lot. And based on the choices that you make on what type of abstractions and how you want to deal with, the abstraction debt actually comes into play. And these are basically short-term decisions that you take for your platform without understanding the long-term impact that it will have in your platform. So the moment a request comes in, you decide to do something, and you're like, hey, it works, but then you don't look at the bigger picture. So essentially, this is the cost that is being accumulated to maintain the rigid platform abstractions over time. So as and when the requirements evolve, team will request for more features that are coming in, and then it becomes very hard to maintain these particular changes based on the option that you chose. So how do you get into an abstraction debt cycle? The example that I gave, this exactly fits within the debt cycle. So how it actually starts. So initially, when you are a platform team, you will simplify things. And you do that via abstractions. So you create a platform, you create an abstraction, you simplify things. Then some of the teams will adopt those abstractions. Everything looks fine. Then you have a team coming up and saying that, hey, the abstraction that you have created doesn't work for me. I need a special allowance. Now, because of that new requirements that come in, you essentially add a layer of complexity there, because depending on the 4 options, you choose one of the options. And then that actually creates a separate path which you need to focus on. And then without even you knowing what happened, this cycle repeats. So you create a platform, you simplify things, you abstract it, you have a new request coming in, you address that request, and then which basically becomes non-standardized, and then you are in this particular debt cycle. So the next thing is, what are the warning signs, or how do you know that you are trapped in this abstraction debt cycle? One of the first things is rising custom requests from the team. So when you have a platform out there, and you suddenly notice that a lot of other application teams are coming to you and saying, giving you customization requests that, hey, this feature is not there. I want to be able to tune the GPU workloads, or I want to tune the database size or TTL. Now, when teams come with these options to you, you know that something is wrong with the platform that you have, because they don't have the option to make these changes. Secondly, you will notice over a period of time that teams are building their own workarounds. So if your platform doesn't offer them what is required, they are going to create a workaround for themselves, because they want a particular thing to be out there. They want their features to be shipped. They want their applications to be deployed. So they will take a workaround if there is no other way possible. And then eventually, in the longer time, you will see that there is a complete shadow IT team that's created without you knowing of what's happening. So I think the easiest way, or the easiest sign to figure out, is the rising customization requests. So if you are in a team and you suddenly start receiving a lot of requests from various teams, you know that you are probably getting into the abstraction debt cycle. Now, how does this affect? Once you are in this cycle, what happens is you are actually affecting the entire platform, the entire growth, and the evolution of your platform. So implementing new features become really difficult, because now your entire resource is going into addressing the individual needs that are coming in. So your focus is less on building or incorporating new features. Over time, teams actually lose interest or lose trust within your platform, because they know that whatever I want, the platform doesn't give me. I every time have to go and raise a custom request, which is where they are losing trust, and nobody is actually going to use your platform in the longer run. What now happens is your platform evolution slows down, because you are not able to add anything new value add to your platform, and you are continuously just going there and addressing the custom requirements or custom requests that the teams have. And this eventually leads to newer technologies not being able to adapt or to be added to the platform. So let's say everyone's talking about AI. You want to incorporate some AI agent within your platform. Now, you don't have the resource and the bandwidth to do this because you are busy dealing with the mobile team's requirement. You are busy dealing with the application team's requirement to just standardize or get more features to the platform. So how do you address this debt trap? And one of the ways which I call it is the abstraction elasticity. And by this, what I mean is your abstractions that you create for your platform need to be like a rubber band. It should be able to stretch to a certain extent that it is able to address the abstractions or the requests that are coming in without affecting the core benefit or the core of your actual platform that you have. So that's what it is, the ability for abstractions to accommodate change without breaking. So without me doing any changes to the core platform that I've created, I'm able to add the request to the platform and even support the requests that the teams have. So what are some key indicators when it comes to identifying whether your platform is elastic or not? So first one is adaptability, which basically means can new requirements be handled without changing your entire core functionality of the platform? So when we spoke about the Postgres plugin that the mobile team wants, now, can your platform implement this without affecting the core functionality of the platform that you have? Can you add this feature for your mobile team, or can they do it self-service without affecting the core? That's an answer. I mean, the answer that you give to this question will define whether your platform is elastic or not. Or whether it can accommodate requests. The second one is extension patterns. Now, when you already have a platform in place, if any team wants to make any change or if they have a separate requirement, do you have documented ways on how to do that? So let's say you had some HTTP, some team is using some HTTP REST APIs and they suddenly want to add a new header. So do you have a documented approach on how they can move away from the standardized approach that you have taken as part of the platform, but still include the changes that they need? I'll talk about that a little later as well. Third one is transparency, and this is more for the power users or pro users within your platform. Do such users have the visibility into the platform as to how it uses a particular thing? So for example, if you have Istio implemented, right? So pro users would want to know what is the time to live for a particular request. How is it actually bifurcating the request that it goes to different pods? So a newer developer might not need it, but then pro users would want to have transparency into the platform on how it works, what it does, so that they get better understanding of what's happening underneath. And lastly, there should be some migration paths involved. So you should basically show them how easy it is to move away if abstraction is necessary. So if you have a platform in place and if a team has a new request, how easy it is for them to implement that request within the platform. So these 4 things, critically, they actually help you evaluate your current abstractions. And based on the responses that you give to these questions within your teams, you would know how flexible your platform is. So another few questions here which you can ask within your team. So can teams access lower level controls when necessary without abandoning the abstractions entirely? And by this, what I mean is that, let's say you have a data processing service that uses a specific JVM memory settings, for instance. Now, you would want to know that whether these settings can be configured by the standard default implementation that you have. So this is the lower level configurations that the team want to do. So is your platform capable of doing that? If the answer is yes, then your platform is fairly flexible to accommodate requests. Similarly, you talk about the another question could be, do users understand what's happening underneath when they need to? This is more about the pro users, which I spoke about. So same example, when a developer service is experiencing a latency, can they go within the platform and see the Istio implementation and understand why the delay is, why the latency is coming in for their request? Can they go in and configure the timeouts which actually impacts the service? So this is another question that you can ask your team. And then another way could be, are there any documented extension points where teams can customize the behavior. And that is where things like the HTTP responses that I spoke about. If there is a new header request that the teams want to put in, do you have a documented way available where the teams can go ahead and extend their application with the newer header that they want to do? So these are a few questions that you can ask, and based on the response, you can decide, or you'll get to know how flexible or rigid your platform is. Another few choices that you can make. So let's say a team needs a specialized PostgreSQL extension for geo special queries that aren't in your standard database abstraction. And this is the same mobile app dev team that I spoke about. So there are two ways you could address this. The first one is you can definitely go ahead and add more configuration parameters into your core abstraction. But then this is not the right way, because you are increasing the complexity of the entire interface. Instead, what you could do is you could create different multiple interfaces. A simple one for the basic needs, more developer-friendly, a more platform engineer-friendly, different interfaces, which will make it easier, which will make it a lot more flexible for you to deal with further abstraction requests. Similarly, an ML workload requires specific memory and CPU settings that don't match your platform's predefined resource profiles. And this is essentially, if you want to deploy a sandbox application and you have set a hard limit that you cannot use more than X GB of memory, X GB of GPU, how do you deal with that, So a bad approach here would be creating predefined t-shirt sizes that, hey, these are the 4 buckets I have, and that's the only way you can use your application here. So in this, what will happen is either you will be under provisioning or over provisioning the resources because you have a fixed bucket size. What you want to do is you want to implement policy-based guardrails so that you have a flexible platform, and based on how the request is, you go ahead and ensure that your platform behaves in that way. You are given a particular resources based on the workload type the team is requiring. Similarly, a team needs a infrastructure configured in a way in which your standard templates don't actually allow, right? So you can create a template with dozens of parameters for every account with every variation. This again leads to more number of configurations, more YAML files, more complexity. Instead, you can create building blocks, ready-made blocks, which teams can just utilize for building their applications, which will make sure that they are still in compliance. There is a standardization process in place, and they're still able to increase their abstraction. So how do you break the abstraction debt trap? What we discussed until now was various situations where how the abstraction debt increases over time based on the responses that you give. Now we'll look at some patterns on how you can break it. And this is more or less based on the choices that we made. So one of the easier things to do over here is use the layered abstraction pattern. So you can have simple defaults at one level. Then you can provide configurable options. And then you can escape hatches for the pro-level user. So for example, if you see here, a simple database abstraction is where you just give them a minimal configuration. So you can see all they can choose is the size and high availability, which are two values. But then if you want to extend this functionality, you have a separate template here. Now where you provide them with more options depending on the use case. So here, they can choose the different extensions that you have already defined as the platform team. They can choose a backup schedule. They can choose the retention options. And if you have a further advanced team who needs more fine-tuning, you can create another template here or provide them with more options where they can choose the buffer size, where they can choose the maximum connections, working memory, so on and so forth. So if you see here, you have different layers. We start with the default layer, which is very basic, and then we get into the developer options, and then we get into the advanced way. Similarly, you have a progressive enhancement pattern where you can drive your teams from basic to expert approaches. So here also you can look at a basic API, which is here, where they can just choose the name, image, and replicas for the application that the team is building. For an enhanced option, you can give them more control by allowing them to change the resources. We talk about CPUs or memory that's needed. They can also control the auto-scaling options. So these are the things that they can do for DevOps, for DevOps teams. For platform teams who need further control, you can give them security options that they can run it as a root user, for example, or they can access file system, because this is not what a regular developer might need. So this is one way where you can tweak your API patterns so that it is able to address all the requirements for different types of users. Lastly, I spoke about policy-based guardrails when I gave the example of the MLOps workloads. So in this case, you can define policies, and based on the policies and the requirements that come in from the team, the policies will be enforced, and that will ensure that the abstractions are taken care of while standardization still stays in place. So if you see here, you have, for example, you can create an OPA policy for different environment and database-related policies. So you can say that, hey, this is the requirement that is necessary, and you have to, abide by it. And then based on the environment, if let's say if it's a developer environment, you probably don't need a backup rule over here. However, if it goes into production, or if it's in a integration integration environment or a pre-prod, you might need to implement some other features. You might need HA, you might need retention, you might need backup. So those are the options. These are the policies that you can create for a particular environment. Similarly, if you are talking about PostgreSQL, the example that I gave, so you can define the extensions there that if it's a development environment, these are the options that are available. If it's a production environment, these are the further options that the team can use. And lastly, if there is a extension request that comes in, so you can create a specific CRD, let's say if you're in Kubernetes, right? So you can create an extension request that actually depends based on the requirement of the team, and then you can decide how you want to deal with it. If it's a time-based requirement, if it's a resource-based requirement. So you basically set up policies which will ensure that the abstractions are taken care of, as well as the standardization stays in place. So what's the result of all of this, right? We spoke about the abstraction debt, how you get into the cycle, how do you identify that you are in a debt cycle, and how do you get out of it with the various patterns. So if you see here, what you'll do is you'll improve the adoption, because now newer teams can come in and they exactly know that whatever I need, my platform will support. So you will have more users adopting the platform. You will eliminate shadow IT teams because, again, whatever they need, your platform is providing it. User satisfaction will definitely improve. So a lot more developers within the teams will want to use the platform. And lastly, you are reducing a lot of overheads now, because you are listening to what the teams need, and your platform is fairly flexible, to make the changes. So yeah, that's pretty much what I wanted to talk about, the whole abstraction debt cycle. And I hope you found this interesting and helpful. A couple of QR codes, which I would like to share. The first thing is the platform engineering ebook. So this is something that we created at InfraCloud, and what we have done here is we have worked with our customers and as well as my role in the platform engineering community. So you will see a lot of reference architectures, how to navigate your way when you are building platforms. So you can get the ebook from here. Secondly, I'm very proud to say that the next KubeCon in India is happening in my city in Hyderabad. It's happening on August 6th and 7th, and I'm super excited for it. And I invite all of you to please come to India, visit Hyderabad, be here at KubeCon, and I would be the best host possible. Since I'm a food and travel blogger, I'll give you the best places to go and eat biryani. So looking forward to seeing all of you at KubeCon India. And yeah, that's all I have. Do leave your feedback for the session. It will help me improve. And if you have any further questions or anything interesting to discuss, I'll be around, and you can discuss with me. So yeah, that's my time. Thank you.